Well, good morning, everyone. I'm Jeff Tucker from WTHI TV in Terre Haute, and I'm a member of the program committee for the conference. I hope everyone had a chance to visit some of the exhibits during the break. Thanks again to the Telos Alliance for their sponsorship of the morning break. This breakout session is focused on drones and how they can be used to inspect towers more frequently and less expensively to find problems not obvious from the ground. We are pleased to have Paul Shulins with us today to speak on this topic. Paul is president of Shulins Solutions, a radio and TV broadcast consulting firm that specializes in remote control solutions, studio design and construction, antenna protection systems, and rating metrics. Before starting his own company, Paul worked at Burke Technology as vice president and chief technology officer. He also worked for nearly 30 years at the Greater Media radio stations in Boston. Paul is a frequent contributor to Radio World magazine and has authored several chapters in the 11th edition of the NAB Engineering Handbook. He is active with SBE and IEEE and currently serves as the vice president of IEEE's Broadcast Technology Society. Please welcome Paul Shulins.
Thanks very much for that kind introduction, and the bio's just a little out of date. I'm now serving my first of two terms as president of IEEE BTS, and I'd encourage everybody to look into that organization because it's pretty good in terms of going in depth and rubbing elbows with some real movers and shakers in the industry. So today I wanted to talk about drones and thermal imaging. In particular using drones. As was just mentioned, my company is Shulins Solutions, and I do remote control systems as well as RF protection systems for towers. Just a quick little plug here for the IEEE Broadcast Technology Society Symposium. We're back to in-person meetings after things have calmed down after the pandemic. We're going to be in Washington, D.C. this November 14th and 15th at the brand new NAB headquarters. And we've got a great program that was just put together. The registration site is up, and it's at bts.ieee.org. So please consider coming to that. It's not too far from here if you're in the local area. It's really gonna be a good show. So I wanted to talk a little bit about infrared and drones, and I'm going to start out talking a little bit about the theory of infrared. Infrared radiation was first discovered in about 1800 by William Herschel. He was a scientist and astronomer and composer, and he first used sunlight in a prism, and he realized that different colors were broken up by a prism, and they represented different temperatures. And he found out that red light was the warmest, and the area beyond red was even warmer, and he wondered what was there. He also has some impressive credentials behind him. He, like I said, was an astronomer. He discovered the planet of Uranus. He actually did some early spectrometry work in the late 19th century, breaking out different wavelengths of radiation from different distant heavenly objects, and was able to figure out what these stars were made of and the composition. So he was well ahead of his time. So what is infrared? Well, infrared is classified as electromagnetic radiation, and it's longer than visible light, and it's generally invisible to the human eye, 700 nanometers to about 1 millimeter of the wavelengths. And there's no hard limit to what we can actually see with the eye, so that makes it a little bit dangerous because you can be looking at infrared radiation and not realize it, and you can damage your eyes. So that's something to always be aware of when you're dealing with infrared. One concept that was new to me, and I've done a lot of training to try and understand how infrared works, is the concept of emissivity. And if you're not familiar with emissivity, it's really the measure of how an object deals with heat, how it radiates heat. And really, when it comes to using an infrared camera or an infrared detector, it will tell you how well the detector will actually tell the truth about the temperature of the object you're trying to measure. So emissivity values range from 0 to 1. And in general, if it's at 0, it's a perfect mirror that reflects all the energy. If it's at a value of 1, it's called a black body that perfectly absorbs and radiates all the energy. So if an object has an emissivity close to 1, it's really easy to measure the temperature because all the energy is being reflected. If you're measuring an object that has an emissivity value that is below 0.5, you're unlikely to get an accurate reading of those temperatures. And in that case, you might need to put something on the object you're trying to measure, like electric tape is a great substance for doing that because it has an emissivity that's very high, about 8.85 to 0.90. So when it comes to looking at different objects, this slide shows what happens if you point a infrared camera at a paint can. And you can see here we've got a piece of electric tape on the paint can, but the paint can, the rest of it is really shiny. So you look at these spot temperatures on the right-hand side of the screen, and you can see 163.1 degrees with the electric tape and only 74.3. Well, the actual temperature of that can is about 160 degrees. So if you're just measuring it without the electric tape, you're not getting an accurate reading, and that's really important to understand, especially if you're in a controlled environment, you're indoors, you're measuring circuit breakers or RF combiners, transmission lines, that kind of thing. In fact, this table gives a sample of emissivity for various materials, and I've highlighted at the top, you can see copper has an emissivity of 0.05, which is very low. So if you're taking a drone or infrared camera and you're going up a transmission line and you're looking at the temperatures, you're not going to really get an accurate temperature from copper that's new. Even copper that's oxidized, that's been up there for a while, you see the emissivity value is 0.65. And I'll talk about actual values versus relative values in an upcoming slide. But you can see various different objects have different emissivity values. And you might look at the third one from the bottom there, food and organic materials has an emissivity of 0.95 and 0.97. And maybe that's why microwave ovens seem to work so well. So applications for using a drone and infrared imaging when it comes to RF and broadcast, there are two ways of doing thermography. There's qualitative and quantitative. The qualitative is using the skills and training you have to understand and interpret thermography by looking at the images. And you can look at objects like solar panels, rooftop antennas, broadcast transmission lines, and that's the kind of thing I'm doing here and talking about. The other way is quantitative when you're in a closed environment. So let's say you're in a building where you don't have wind and you don't have different humidities and all these other things that you can't control. Well, then you can do numerical measurements and you can use calibrated instruments to get exact temperatures. So if you're inside and you're looking at a circuit breaker panel, that's where you can use a calibrated instrument and actually get a real temperature. What I'm going to talk about here is using drones and obviously outdoors to get measurements on towers, and you can see that that's going to all follow under the qualitative measurement. Well, how does it work? The detectors use various components like vanadium oxide or amorphous silicon to receive the electromagnetic radiation. This changes the electrical resistance on the chip, and these changes are measured and processed by a computer into digital signals, eventually putting together a picture of the thermal gradients. So what do we use drones for in broadcast engineering? Well, the primary uses are obviously tower inspections, right? You can make a tower inspection visually very easily with a drone. You can do the IR scans for heating. Some people use drones for RF pattern measurement, which is a lot more efficient than driving around or a lot cheaper than getting a helicopter to do those measurements, as well as thermal imaging of AC power power panels, and that's just obviously a thermal measurement, not using a drone indoors. So why do we use thermal imaging? Well, it really helps us to detect electromagnetic radiation that we can't see. It gives us another sense. We have 5 senses. This gives us a 6th sense of really what's occurring in the environment around our electrical and our RF systems. And some of the applications for IR are broadcast transmission lines, broadcast antennas, patch bays, RF patch bays, combiner modules, switches, and electrical power panels. So I'll talk a little bit about the aircraft. What is an SUAS? It's defined as a small unmanned aircraft system, and it consists of the aircraft, and it's got to weigh under 55 pounds. It includes the aircraft, the system on the ground, the remote controller, and also the operator is part of that system as well. Small aircrafts allows us to inspect areas on the tower that are not easily accessible. It's obviously safer and less expensive than a tower crew. It really can't take the place of a tower crew, but it can make the tower crew's job more efficient and safer because you can identify areas before the tower crew goes up that you want to have them concentrate on, and you can get them up and down the tower much quicker, and they don't have to look as much for problems on the tower because you can identify them here. You can also fly in a wide range of weather conditions. The drones these days are pretty waterproof, and so you can get a drone up there in conditions where you would not normally get a tower crew up. Tower crews sometimes need to schedule these things weeks or months in advance. Obviously, it's easier to get a drone and try and fly on short notice because you don't have to have a mobilization like you do with a tower crew. And to provide views also in places where tower crews can't be, like above the tower looking down on the tower. So there are some practical things that you have to follow. It requires a Part 107 pilot to operate the drone. There are regulatory conditions that also requires a second person as a qualified spotter. So we never fly these drones by ourselves. Most often, it requires FAA and local approvals to fly above 400 feet above the ground. There are some rules that allow you to fly 400 feet above the tower as well. But local conditions, such as your proximity to airports and stuff like that, all play into this. So there's usually permissions that are needed, especially in larger cities where you have 1,000 and 2,000 foot towers. So I subscribe to a service that helps me get those waivers whenever I need to do something there. And of course, we talk about liability insurance. Should something happen, you want to be covered, as well as hull insurance for the aircraft. Question I get is, how much do these drones cost? Well, these are not these are enterprise class drones, so you can buy your $500 drone and probably get some half decent pictures. But there's always the RF problem there, and you want to make sure you have some equipment that is designed to work in harsh environments. So in terms of cost, the drone I have is between 30 and 40K. And that's mostly because of the shielding. This is the kind of equipment that power companies use to look at high voltage lines and things like that. So we want to be sure when we're around towers that have multi-million-dollar operations that we're operating safely and we have that kind of equipment. I always get questions about how much does the drone cost? Well, there's a lot of different possibilities there. So also get questions about FAA rules and regulations. The pilot certificate's required to operate under Part 107. You must be at least 16 years of age. You need to take a test. It's not a hard test. You study for it, and just about anybody can get their license. You have to register your drone, and they want them all marked now, so you put a permanent label on the drones. If something should go wrong, they can identify where it came from and who the operator is. And if there's an incident or accident causing significant amount of damage or injury to anybody, that has to be reported to the FAA. So they've kind of clamped down on this pretty tightly. Also, it's important to keep the drone within line of sight at all times, and If you're a visual observer, you can only be an observer for one drone at a time. Also, these are normally limited to daytime flights, 30 minutes before sunrise and 30 minutes till after sunset. Obviously, avoiding any air traffic, manned aircraft. And you can also request a waiver of most of these restrictions if you can demonstrate that the operation won't compromise safety, based on what you're asking for. One of the things I'm also going to mention is that when I do these thermal measurements, I really don't want to do them during the daytime because we've got the sun beating down on the tower, and that decreases the signal to noise. So generally, I try and do these measurements 30 minutes after sunset and or 30 minutes before sunrise because we get the best signal-to-noise ratio. And what we're looking for is very small differences in heating along a transmission line. Obviously, you would expect the transmission line to be fairly uniform in terms of its thermal properties. But as I'll show in a slide coming up here, that's not always the case. And when you do find something like that, it's like finding gold because you can tell the operator that there's something wrong here. They can send the tower crew up and you tell them exactly where it is and they take it apart and they can fix it. Flight conditions, well, when you're flying any kind of aircraft, you have to be aware of the meteorology. It requires wind speeds within tolerance, and this varies with the operator and the type of skill that operator has. Obviously, you've got to have clearance with clouds and visibility because you need to keep the drone in sight. And again, I mentioned fly at dusk or dawn to minimize the solar loading. And the good part is that you want all the stations to be on the air. So this is very much non-disruptive to the broadcaster. You want to have the maximum amount of heating that you can have on that transmission line so you can see if there's anything wrong when everybody's operating. I also get asked a lot of questions about RF interference because we're flying pretty close to the tower and pretty close to these TV stations, especially that are operating at a high power level. So RF interference cautions, we use RTK technology whenever possible. I'm going to explain that in the next slide. We fly as far away from the radiating elements as we possibly can, but we still need to be close enough to get the resolution that we need. So if we're a mile away and we take a picture of the tower, it's not going to be very useful. But if we're 100 meters away and we have the right focal length on the camera, then we can really tell some detail about what's going on there. So that's what I mean by using an appropriate focal length lens on the camera. And of course, guy wires and obstacles you need to be careful of and never flying over people or animals. So I mentioned RTK technology. What is RTK? RTK, you might hear more about this when you're looking into drones. It's real-time kinematic positioning. And basically what it is an extra base station that receives satellite signals from the GPS system, as well as the drone itself receiving these satellite system, these GPS satellite signals. And what happens is with this, you're able to apply a much more precise correction to the calculations that are done in the drone as to what its position is. So as you can see in the lower right, there's this tripod with this object on it, and that's the RTK base station that has its own compass in it, and it also has a receiver for satellite GPS signals. So it transmits to the drone as well as the drone getting its information from the satellite. When this all works well, you get positioning to within a few centimeters. And this helps the drone correct its position. So if you have wind and other factors that are moving the drone around, it realizes the drift and can correct it very quickly. And that's really important when you're flying this close to towers. And I think I just covered this slide here. And this is a little better picture of what that RTK mobile station looks like. So again, I was talking about the qualitative versus quantitative a little earlier. And one of the things that really surprised me when I started learning about using a drone in thermal imaging is that it's meaningless to specify or compare precise temperatures. I thought getting into this, it would be a lot of fun. I could run up the tower and say all these points on the transmission line were a certain temperature. And then I can come back a year later and say, no, something's changed. Well, that's not really the case, because bullet point 3 here says a 3-mile-per-hour wind can cut the temperature reading in half. And that's just the way thermal imaging works. So it's obvious that the chances of you doing these measurements when there's absolutely no wind is close to 0. So basically, the value of the thermal imaging is to detect uneven or unexpected energy loss, and not so much to look at the absolute value of those readings. So when I do this, I'm using my skills as a certified thermographer to look at the images and to understand where there are thermal differences and thermal anomalies, where I can include that in my report and let the operators know that there's something going on with their antenna or their transmission line. Also, the emissivity, I talked about emissivity earlier, of different components produces dramatically different thermal indications. So if you have a label on your transmission line, you need to take a picture of that with a RGB or a regular camera so you can identify that, because that label is going to look like a thermal anomaly because of the different emissivity of the paper or metal or whatever that label is made out of. So there's some work to be done prior to running these drones. I talked about how close you need to be to the tower, how far away you need to be to the tower. Most of these thermal imaging cameras do not have interchangeable lenses, so it's important also to get a lens that will give you the right spot size ratio. That is the best resolution that you can want. For example, if you're taking a picture of a rooftop or a solar array, you might want a wide angle lens so you can get the whole thing in. But in this case, where we're imaging very small sections of transmission line, we probably want a focal length that is higher, and we can get a different spot size ratio. So this shows the importance of choosing that correctly. This is the aircraft that I've been using. I've now upgraded to a 300, but this is basically what it looks like. It has 2 payloads. You can see 2 cameras on there. One is the RGB camera, and the other is the thermal camera. So we can get those RGB images as well as the thermal images at the same time. This is the FLIR camera that I've been using. It has a focal length of 19 millimeters. It gives you this resolution, and you can also take movies with it at 30 frames per second. So if you're ascending or descending up and down the tower, you don't have to keep taking pictures. You can get 30 frames a second, and each frame will be captured. Radiometric images are just like JPEG images, except there's additional data captured in the file. And it assigns a temperature value to every single pixel in the image file. So this is what we capture with thermal cameras. Most cameras, whether they're handheld or they're on a drone, the result is they give you radiometric images that can be later processed in the software. This is another camera that you saw on the earlier image of the drone. This is a Z30 camera. The resolution of this is only a 2.13 megapixel sensor, but you look at the resolution. It's 640 by 480, which is nothing to write home about, but it's got a 30 times stabilized optical zoom, and I'll show you some pictures that were taken by that camera in some upcoming slides here. This gives you an idea of the controller and the display that comes with the drone. This is an overall picture of the operation, and again, some of the things that you need to look at as far as safety goes, having emergency phone numbers and hard hats. These drones can cause some serious damage. There's a story of me at NAB one year, and I had one of those consumer drones, and I tried to catch it as it was landing, and it hit my forehead, and I was walking around NAB with a big Band-Aid on my head. So I was lucky I didn't lose an eye or anything like that. So these propellers are very dangerous and need to be respected. So here's some examples of some thermal imaging. This is a cellular array at 150 feet. What you're looking at here are the electronics that are heated up a little bit, not the antennas themselves. Um, These are energized transmission lines. You can see that they're lit up and fairly even, and you can see in the background there a telephone pole with a transformer on it that is hotter than ambient. And this is one of the better success stories that I had. This is a tower in Boston. They were getting VSWR and arcing problems. They couldn't figure it out with a ground-based TDR or spectrum analyzer or anything like that. I took the drone up, and you can see the left-hand picture is an infrared shot of a hot spot on the transmission line. This is a fairly big line. I think it was 8-inch line, and it was up at around 400 or 500 feet. And you can see from the right-hand picture, that's just a visual picture. There's absolutely no indication anything's wrong. So we figured out exactly where that hot spot was. We had the tower crew go up, and this is what they found. It was an O-ring that was never installed properly, and it had dropped down onto the Teflon insulator and caused these intermittent problems. So it was a really weird one, and I think without the thermal imaging, it would have been really, really hard to find. We can also display these pictures with different palettes. So the software that you can use to analyze these radiometric images is really quite powerful. And there's really no right or wrong choice for the color palette selections. Some palettes are effective better for other applications, but this is a demonstration of different palettes that can be used to highlight the areas that you want to identify as problems. There are a lot of things that you can fix in post-processing with the powerful software that FLIR offers, but some things you can't fix. And those are focus, range, and distance. We call it forward. And basically, if the image is not in focus, you're out of luck. You can't refocus it after you've taken the picture. So you want to make sure that the focus is correct. You've got to be in the right temperature range of the camera itself. You need to be close enough to the target to get that resolution that you're looking for. And so these things are things that need to be carefully looked at when you're on site with the drone. And some of the effects of messing up the focus include flying too high or fast, or if you're yawing too aggressively, or if you have a gimbal issue, or if there's very high relative humidity. That can all impact the focus. Also, there's a concept called stretch, and we are capturing all this information with the thermal camera, but we're not necessarily interested in the sky background. So what we can do in software is we can stretch the image and ignore thermal conditions that are not relevant to what we're trying to do. So this slide demonstrates that we can take the range and span and adjust it to exactly what we're interested in. 5 minutes? Okay. We'll make it work. This is a practical example of some of the radiometric images that I've taken. This image on the left is a TV UHF antenna. Same antenna on the right, but with the thermal imaging, you can see the power dividers inside. And you can take this image back to the manufacturer and say, check out the blueprints here, make sure that these are the thermal effects that you would expect from something like this. Handheld camera. This is indoors in a controlled atmosphere, and you can see some of the Teflon spacers that are inside the transmission line. And I'm going to skip by a couple of these. I wanted to show you some of the RGB images with that 30 times zoom I was talking about a minute ago. You can really get close-up pictures. For example, on the left-hand side, we're inspecting the beacon. You can even read the barcode off the side of the beacon there. So you can really get close up. And again, this is where when you have a tower crew and you see something wrong, you can point it out before they start climbing. An example, this is 400 feet up on an FM tower. This picture on the right and on the left is where a pole attaches to the top of the tower, and you can actually see that the bolt is secure there. Electric tape, used. We wanted clamps on there. The owner didn't know that electric tape was used, so we had the crew go up and take the electric tape off and secure it properly to the tower. So anyway, I think I'm on time here. Here are the conclusions. Drones can be used in many cases to perform visual and infrared imaging. You do have to have the proper certification and the authorization in the airspaces. Interpreting the images does require a skill set. There are various certifications for thermography. I'm a level 2 thermographer. There's 3 levels. Level 3 is actually for instructing. You can really get fooled by these images if you don't have the proper training to look at them and interpret them. And of course, drones can also be used for, the visual and the RF signal measurements, which other companies are doing as well. And again, using these drones for inspections will enhance safety and lower the inspection costs. These are some handy resources. If you're interested, you might want to take a picture of this slide, or I think it's going to be available afterwards. But there's my information. Infrared training is available at a couple of these locations that I've pointed out here. And, excuse me, Flare Tools software, there's some free software on the web for processing images, whether you've taken them with a drone or a handheld camera. And also a lot of free training on YouTube from ITC and FLIR. If you put those names in, you'll get a lot of stuff there. Quick thanks to FLIR, Bill Schwan, he's a level 3 thermographer and my instructor, the Infrared Training Center, Florida Drone Supply, Jim Steinberg, who was with American Tower and allowed me to do a lot of inspections on their towers. Gary and Cindy Cavell are also experts, and they do a lot of thermal imaging as well as Jim Leifer for American Tower. So I think we got 2 minutes left. I'd be happy to take any questions, and there's my phone number. If you'd like to contact me, please do. Shane? Yeah, that's a new technology, and it's tied into ADS-B for regular aircraft, and it is. I don't have it yet, but it's coming on, and it will be required, and it's going to allow the FAA to figure out what altitude you're at and where the drones are. I don't honestly know too much about it because I'm not participating in it yet, but it is something that I think all drone operators are going to need to, at least commercial drone operators are going to need to comply with. Yeah. Yeah.
How high of an RF field can you get into before you lose the telemetry with the drone?
Yeah, that's a good question. I get that asked that a lot. I mean, I've been in 1 megawatt, RF fields at about 10 meters or so, and I've had some effects. But these drones, these enterprise class drones, are manufactured so well that if they lose telemetry, they know what to do. In other words, I have mine programmed to just descend or ascend, and it gets out of that RF field. Most of the problems I've had are pretty benign, where you lose some readings, but the camera itself is still operating and getting the images on the SD card, which is on the camera. I've never, had a control issue with that. And again, I wouldn't advise using, anything that's not enterprise class, especially in these high RF environments. Okay. Thank you very much for your time, guys.
Thank you very much, sir.
You're welcome.